Hello everybody, it's Amell, and today I'm going to teach you how to solve the count primes problem. Count the number of prime numbers less than a non-negative number n. For example, if the input is 10, the output is 4. Why? Because there are 4 prime numbers less than 10. They are 2, 3, 5, 7. As you know, a prime number is a number that is only divisible by 1 in itself, and it is greater than 1. So, how can we solve this problem? The brute force approach is to use the trial division method. For instance, we can check if a number is prime in big O square root of n time, where n is the number. We can just check if the number is divisible by any number between 2 and the square root of n. If that's the case, the number is not prime. So why we don't have to go past the square root of n? Because if a number is divisible by any number that is not 1 in itself, it has to be divisible by a number between 2 and the square root of n. So if we use this method, the trial division method, we have to go through all the numbers less than n using this method for every number to check if it is prime. If it is prime, we increment the final result or the count variable. So because we have to go through n-1 numbers checking if every number is prime, the time complexity of the brute force solution is big O of n times the square root of n. So can we do better? Yes, we can do better. What we can do is that we can use an array of Boolean values initialized to true. All the values initialized to true. So if a value is initialized to true, it means that that value is prime. So initially we're making the assumption that all the values are prime. But what we do is that we start from 2, which is the smallest prime number, and we increment the final result variable or the count variable. But then we sieve all the multiples of 2, because the multiples of a prime number cannot be prime. And this method, this solution, is gonna give us a better time complexity. The time complexity will be big O of n log n. And this is called the Sieve of Eratosthenes. We sieve the multiples of a prime number whenever we find it. That means that we set all the multiples to false in the array so that they are not considered primes in the future. So we take them out of future consideration. They cannot be prime. So without further ado, I'm going to show you how to write the code. First, I need a variable integer result gets a value of 0, and this variable is for the final count, how many prime numbers there are less than n. Then I need an array of Boolean is prime gets a value of new array of Boolean of size n. And as I said, I want to initialize all the values to true. So arrays that fill is prime to true. So now all the values in this array are true, to indicate that all the values, we are making the assumption that all the values are prime. Okay, so now we say for integer I gets a value of 2, I is less than n plus I. Then if the number I is prime sub I, if it's prime sub I, then we have found a prime number, so we increment the final count plus result, and then we need to sieve all its multiples because they cannot be prime, so we need to take them out of future consideration. So we can say for integer j gets a value of I, j is less than n, j plus equals I. And why do I say j plus equals I? Because that way I can find all the multiples of a number, and then I can mark those multiples as false. So for example here, the first prime number is 2. Because it is a prime number, it is true in the array, so we increment the count. But now we know that all the multiples of 2 cannot be prime. For instance, 4 cannot be prime, 6 cannot be prime, 8 cannot be prime, 10 cannot be prime, and so on. So what we do is that we mark that in the array, in the is prime array, we go through all those multiples by saying j plus equals I, and we say is prime sub j gets a value of false. That means that this value cannot be prime, so we will not count it in the future as prime. And at the end, I return the final result. The time complexity will be big O of n log n. So I'm gonna run the code. It seems to be working fine. I'm going to submit a solution. Alright, this is working perfectly. So if you like the video, please press the like button. Don't forget to subscribe, and see you next time.